Just preparing the screen. Awesome. So hello everyone and welcome to the Node Workshop Part 2 by SES in collaboration with Autodesk. First of all, thank you so much for attending. I know these are really strange and difficult times for all of us, but you still took the time to invest in yourself and learn something new. Some of you are probably even in vacation right now, but you're here, so that really says a lot about you, that you really want to advance your skill set. And today we're going to be learning Node, but this is an installment to the first workshop. But don't worry if you didn't go to the first workshop. I would give a quick rundown of what we discussed there, but this workshop would be focused more on some of the intermediate and advanced stuff. So few reminders before we start. I sent the Notion link on Slack. That would be the material that we're gonna look at today. I'm gonna explain that in a bit, but just a reminder that there's probably like around 30-second to 1 minute delay from my machine to the YouTube stream. So if you ask me a question, it's just consider that delay for me to respond. And I might not be looking at the YouTube stream as well, or the chat there. So if you have anything, the Slack would be the best way to ask and say something. Also about the stream, try to keep it in 720p if your machine or internet can support it, because I find that if it's lower than that, you may not even see the text in the screen. But I'm gonna put a poll later in Slack if just to see if everyone's good with my current setup. And yeah, so I'm gonna start sharing my screen here. All right, so right now I have let me just. Right, so right now I have this Notion page that I sent you. So we're gonna be looking at this most of the time. So these are the things that we discussed in part 1. We're gonna jump into part 2, but before that, a few introductory stuff. Personal intro. Yeah, so I'm Lenny. For those of you who attended part 1, you already know me, but for those I'm Lenny, and I'm a web developer at Autodesk on the Shotgun team. I graduated at Concordia University in Montreal with a concentration in web service and applications. And for those of you in Montreal, yeah, shout out to Concordia. I'm a mentor also, so reach out for details. If you're in web or you're interested in web, I could probably help you out, or at least point you in the resources, things like that. Since this workshop is online, I wouldn't be able to show up my stickers, so that's the stickers that I have in my laptop. They're not really updated because I graduated, so I couldn't go to hackathons anymore at some point. And yeah, that's me at Hack the North. I have a lot of other pictures, but yeah, that's one of the better ones. Some personal plug. That's my website. That's my Twitter. I try to post really useful stuff on Twitter, so follow me if you're really into web. I try to post a mix of front end, back end, and I do this 100 days of code challenge, and follow my journey. If you're into web stuff, email dev2. It's a really good community. LinkedIn. So you've seen this part before because this was sent to you as part of the registration. So make sure you're in Slack, because like I said, it's gonna be all there. I'm gonna put polls there. I'm gonna put all the API keys there and some snippets there. So make sure you're on Slack. At this point, you should have GitHub and VS Code already. If not, try to do it right now. I guess it should finish installing quick. Node, it might take you more though, so I really hope you got through this part, and also the MongoDB Atlas, because we're gonna jump to the database part right away. So make sure you have the connection string that we're gonna use for this one. So we're gonna skip through that, and before I start, a little plug for Autodesk. Uh, Autodesk is a company that develops software for architecture, engineering, construction, manufacturing, media, education, and entertainment industries. Uh, these are some of the software that Autodesk makes, and some of them might be familiar to you. But actually, Autodesk existed since about 30 years, and we develop products that allow you to make anything. So that's the whole concept. Whether it could be a building, a bridge, shoes you're wearing, you're designing something, you're trying to make a game, a movie, or a 3D model. Uh, you know, Autodesk has some software that can help you do that. In terms of construction, we have AutoCAD for computer-aided design and drafting, Revit for building information and modeling software. For manufacturing, we have Inventor and Fusion 360. And in Montreal, we actually do the media and entertainment software. That's why I'm based in Montreal. But right now, the office is closed, so too bad. The office is actually pretty cool. So we have Maya for 3D computer animation and simulation, 3ds Max for 3D modeling and rendering, Flame for 3D VFX and finishing, compositing, and editorial finishing, Arnold for global illumination rendering software and ray tracing, and finally Shotgun, that's my team, project management, creative project management and pipeline tools that help creative studios track, schedule, review, collaborate, and manage their digital assets. So what we're trying to do in Shotgun is we're trying to help unify visual effects, animation, and games team of all sizes. So one way that my coworker kind of tried to put it is Shotgun is like a Jira in a GitHub, but for movies. So a little plug here, kind of an FYI too. In the last Oscars or Academy Awards, some of the movies there, some of them you probably know: Avengers, Lion King, Star Wars. The studios that made those movies were actually using Autodesk software like Maya, Arnold, Shotgun, and Flame. And then Shotgun, if you know Ubisoft, EA Sports, Game of Thrones, the studios and the movie studios and game studios of these AAA games and these really well-known series. They use Shotgun as well, some of them. So that's there's some links here if you want to learn more about that. And I have this short video from Autodesk. So thank you, Autodesk. And I just want to kind of reiterate that I was saying before, I work at Shotgun with the web developers in front end and back end, and kind of in my personal time, I really like learning about programming and web development, and especially that's why I do these kind of workshops to really advance my knowledge, but also to share my knowledge. That's why I like doing these workshops, to really explore these web technologies used in the industry today. And today I would like to share what I know about Node and hopefully inspire you to create your own web apps and kind of just get started. And in line with that, this is really what Autodesk's Auto Education Outreach program is about. We promote STEM education, science, technology, engineering, and mathematics, and we hope to inspire you to make anything. And Autodesk is providing some Uber Eats gift cards to the ones who registered early and who are here today. So yeah, we'll keep you posted on that. So yeah, we hope to fill your hunger for some Uber Eats and especially for learning Node. So thank you, Autodesk. All right, so I'm just gonna set this up. All right, so starting officially with the workshop, this is what you're gonna do. You probably saw this in the slides too. Why do we need the server? This is kind of just a quick, this is a really joke on Twitter that I saw. Why do we need a backend? Why not just connect your front end to the database? We're gonna see this later, but basically, we need the backend for a lot of things. That's why we're doing this workshop, is also to have kind of awareness on these things that happen in the backend. Especially if you're a front end developer, you might not know about all these things that happen in the backend. So it's that's why this workshop, it's not really just about Node. It just happens that we're using Node as our tool to do these things, but a lot of the things in this workshop are kind of just general backend development stuff, web server, application things. So all of those things, these are the companies that use Node, some really big ones there. So it kind of shows you that it's an important technology to learn. I think that's the point I'm trying to make here. Yeah, we're gonna skip ahead to really save time for the important stuff. We're using Notion, so there's some breadcrumbs on the top if ever you're trying to navigate. So your best bet is to just go to the Node Workshop homepage. I'm gonna go there, and then you have access to all the things here. So if ever you get lost navigating, just go there. At some point, you're also gonna get some breadcrumbs like that, and then you can search in the page. So it's a lot of material, but try to not get overwhelmed. Again, I'm gonna give you some time later to either digest the material, and also I prepared some challenges at the end of the chapter, so try to do them. No pressure. Kind of really try to focus on of the phase that you're learning. Try some of them, but and perfect time to ask questions also when I give you that break. And don't hesitate to ask questions. Once again, the Slack is really for that. And I have a survey somewhere, so I'm gonna put it in Slack later if ever you had to leave early or something. Hopefully you get to finish the whole workshop, but if you have to leave early, please fill it out before you go. Few more introductory stuff. Yeah, so the structure, the document and code, we have chapters, and then for each chapter we have a GitHub branch. That's why it's really useful for you to have a GitHub here. We're using GitHub, so whenever you go through the material your own, you could just git check out, see chapter 1.0. So while you're following the material on your own later, you can actually try the code as well. We're using nodes, so npm install if once you switch branches, and then npm start. If there's an error about a missing package, just do npm install. It would fix that usually. About the stashing and then committing your own code, only if you really know Git that I suggest you do this. If you made some changes to the code, try to just create a new branch and then push it. But I think the most important part here is that you actually forked the repo, and that you cloned it into your local machine, because you won't be able to do much if you're working directly from the Node Workshop repo. So make sure you forked it and then you cloned it here. Yeah, just some tips here on how I try navigating. So we're gonna have this terminal. I have one terminal where the server's running, then I have another one where I do git stuff, and then I have another one where I do the client commands like curl. So I kind of switch quickly between them. So sorry if if you might not follow that, but as long as you can see that I'm doing git or curl, I think that should be good enough. So I put a few recommendations here if you want to set that up as shortcuts. All right, so I want to give a quick review of what we discussed in chapter 1, sorry, in part 1. So in part 1 we started off with, okay, let me just make my screen wider here. I'm gonna remove my camera for a bit because I wanted the screen to be full. All right, I think that's good enough. All right, so chapter 1 we learned about some basics. We created a server. So we have a running server that has that is serving some web pages. So I'm gonna show you right now how it looks like. But basically, you know, we have a Node and Express server running. We have some routes. We can serve some pages here. When the client goes to this route, we serve this HTML page. So, and then when the client goes to this, we send some JSON data. So let me show that quickly here. Let me split my screen. Okay, so my server is running right now. If I go open tab, so let's see how our server works right now. Okay, so you know that's what we did in part 1. We have a route so that when the user when the client requests that route, we send an HTML. And you could find a code of that somewhere here. Yeah, so that's about it. But this is chapter 1, so I'm gonna see the other stuff after. And then you could also do something like this. Yeah, so this route is serving some JSON data. You could also try that in curl. So I'm gonna go to my curl products. There you go. So it's sending some JSON data. So that means, that was part 1. We had kind of an introduction to how do you set up your server, set up some basic routes, and chapter 1. And then we went to build our REST API. So chapter 1 was more on serving some pages. REST API is more on creating this API so that anyone that can send requests to our server, like a terminal, a script, another server can make requests. So it's basically CRUD. CRUD stands for create, read, update, and delete. So it's basically CRUD over HTTP. That's the whole point of a REST API. So I'm gonna skip a little bit here. Where's that? Okay, so there's a little table here of the things that we did. So we have post, get, post a user, that means create a user, get all the users, get one user, put means update. So when we do update, we also send the payload that we want updated. So you could you also try it out later, the break time. But so yeah, this is kind of the summary of it. So we established these routes for our REST API. We have get, post, put, delete, so that the clients using curl, for example, could send these commands and it would work basically. So try this one, for example, curl users/1. That means we're getting the first user, or sorry, the user with an ID of 1. So the server returned John Doe with ID 1, and then we could try this stuff too to create a user and all that. But I'm gonna save that for the database part, so we can actually see the database changes. So that's chapter 2. All right, so chapter 3, the I kind of sped through this on part 1, so sorry about that if you were there, and I actually kind of sped through it because this is more kind of a cleanup part or refactoring part. So it's a really really important part, but I kind of wanted us to focus more on the kind of the new stuff that you probably haven't seen before. So this, one of the most important parts in chapter 3 is that we have this end file, env file. So it's the environmental variables that you set up for your local environment, and the point is that when you deploy your website later to the cloud, you're gonna have a different set of environmental variables there, and it makes it more secure, because some of these things like API keys we're gonna put in the env, and then you don't have to push it in your Git repo, because if you end up pushing this in your Git repo, that means someone can just go to your GitHub and then see your passwords and then your API keys and stuff like that. So env makes it secure. So for example, right now we have this env, so I'm gonna ask you also later to create your own env, but this is just an example. In chapter 4, this is we're gonna have the connection string, and it's gonna be there, and this is not part of our Git. It's Git ignored, see, so it's not pushed to the repo, so it's secure. Yeah, so that's the whole point of the environment variable. In chapter 2, we also saw modules. So the TLDR on the modules, the summary is that we can do something like this. We create actually I'm just going to show the actual code. So we have this util function, CRUD helper. It doesn't really do much. It just gets the maximum ID inside the user. So let's say that's a functionality that you want to put in a module. You want it to be reusable for the entire code base, so that you don't just put it in one file and then you copy paste to another file. So we're modularizing it so everyone can use it. So you have this function that you want to modularize, you put it in a file, you export it using exports, and then once you want to use it somewhere, like here, you export it. Oh, sorry, you import it. You import it to be able to use it. So you just have to be careful of those directory traversal. There's some plugins in VS Code to even help you do that. And then once you have the reference to that file, you could call that module that you want, like here. So get next ID. So that's there. So that's basically what modules are. And then we did a big kind of a refactoring here of the routes and the pages. So all the pages went in this directory, pages, index, products. There's not a lot there yet, but that's what we're gonna do in chapter 5. All of our API routes went here under API. So kind of really just to organize it, all of our resources are here, foods, those are all the CRUD route handlers for the foods, then products, and then users, and then all of the views ended up here. Right now we just have HTML, so yeah, just kind of like to organize, right? So you have views, utils, which is kind of like helper functions, and then pages, and then routes. Then inside the routes we have the API routes, which is for our REST API, and then for the pages, this is our web server routes. So these routes only serve HTML and not JSON. So these two folders kind of summarize also the two main functions of our server. One is a web server that serves web pages. So these serve HTML, and then the other one is a REST API that provides CRUD functionality through HTTP. So the result is usually JSON, like here, because we call this like in a terminal. We don't really need HTML here. You just kind of want the plain text. And that is chapter 3. Go to the end. And once again, this material would be available to you after the workshop, and probably for a long time, as long as it's useful to you. So if you're kind of missing some of the context here, feel free to look at this on your own time. And if you have any questions, message me in Slack. So async programming, we also discussed that a bit in part 1 of the workshop. The thing with JavaScript is you could write synchronous code, but you could also write asynchronous code, and the asynchronous code is what makes it a bit more complicated. But if you look at the routes that we did, these are actually all asynchronous programming already. Like a route handler, for example, this is an event. When the client goes to /foods routes, we do this event. So the server doesn't just wait around, waiting for your next command. It actually set up such that when the user does this thing, it reacts. So kind of an event-driven programming, or sorry, event-driven. Yeah, so that's the whole point. Event-driven and non-blocking. So we saw that here. We had this whole pizza analogy for callbacks, so that you order a pizza. If it's synchronous programming, you literally stop and wait here until the pizza arrives. So you're literally frozen. You can't do anything. With asynchronous, however, you can dispatch that command, order pizza, and then execution continues to the next line, so you could do something else. And then when the pizza eventually arrives, that's an event. Then you do what you want with a pizza. So you kind of have this nice flow, asynchronous flow. It makes things complicated a bit though, because you could end up with like a callback here like this. With promises, which is kind of a little upgrade from callbacks. You don't have to pass callbacks anymore, but you just attach a then right there. So it's a promise. You just attach what you want to do with the resolution. No more callbacks, but again, you can end up with a promise cell like this, because you're just trying to organize the order of things to happen. So and eventually we saw async await, which is part of the newer standard ES8, so that you could organize your code, your asynchronous code, in a more straightforward synchronous way. So you could do something like this. You could await the pizza, and it would actually wait for that. You don't have to put callbacks here. You don't have to put promises here. It would actually wait until this thing resolves, so you could eat the pizza, and all those kind of patterns for asynchronous stuff. These things are what we're gonna see on the database. This is a nice comparison actually. In terms of the Node API, you can read file in two ways. You could read a file synchronously, and you could read a file asynchronously. So you could try this example out, and the whole point of this, I'm actually showing this because this is added. This was not shown in part 1. Okay. Yeah, so you could kind of you could use both, but just kind of this is just showing kind of a different structure here. Since it's synchronous, it's straightforward. You wait for the data, you use the data here. In asynchronous, you have to pass a callback there. So that's for like the Node API asynchronous stuff. We're gonna see more of that on the database chapter, where I'm gonna start. But quick kind of a syntax takeaway. So this is kind of a more real life example of these things anyways. And the nice thing, well, the important thing with asynchronous is you're gonna see them also in the front end, so you can't really avoid asynchronous. And I think there's actually a lot of asynchronous in the front end when you're dealing with the events in the DOM. Someone clicked something, but someone clicked this. What do you do first? So it's really important. That's why it's a bonus chapter, because it's not just for backend. So I encourage you to really look at this chapter well when before you go on an interview for JavaScript, for example. Make sure you understand the concepts here, because it's one of those things that just comes up in interview. It's like it's gonna be asked for sure. So you have a callback here. Yeah, this callback based function, it does something asynchronous, and it callbacks, you pass two callbacks, usually a success and a failure, and then what that asynchronous thing does, it would pass the success and failure callback too, so that eventual call would respect that order. So you use it like that. When you use this function, you pass a success callback here, and then a failure callback there, separated by a comma. So that's your arguments. And when you have promises, it becomes cleaner a bit. You don't have callbacks anymore. The asynchronous provider function returns a promise instead that resolves or rejects to something. So here we're returning this thing. We're creating a promise, and inside there we resolve if it succeeds, we reject if it's an error. And then in your consumer, in the code that calls that function, we do something with that promise return here. So this thing returns a promise, sorry, and then we attach a then here for the resolution of that promise. And if something happens, some error happens, we catch it. And lastly, async await. Async await is just a syntactic sugar over promises. So keep that in mind, because once you have an async function like this, you could also call it something like this, right? But here, this is kind of the more useful use of asynchronous. So if you have async await, so you have to put async function for you to await inside, so they go hand in hand. You use a try catch here. If there's an error, you catch it here. But it's more kind of synchronous, that you don't have any callback or promises. And then the way you use that is kind of the same way. That is not indented, sorry about that. But yeah, so you call it kind of the same way. You declare your own async function, and then you await the result of that other async function. And then you do something here, but you can see how much cleaner it is, because you just kind of do line by line programming, instead of doing a then, and then instead of doing like callbacks, which you kind of get very nested very fast. But this one, it's still kind of linear in a way. All right, so that is for the recap of part 1. I'm going to start officially with databases. And like I said before, if you have any questions, I'm just gonna ask you to just put them in Slack if there's anything. Let me just grab some water here. All right, so databases. So cool. Sorry. All right, databases. So from our previous work that we did before for the REST API, one thing that really sucked was the data was not saved. So I'm gonna give you kind of a quick example here. So I have my code here. Actually, yeah, I'm gonna have to go back maybe chapter 2 or something, 2.7. So that should be maybe 2.6. Okay, that should be somewhere in chapter 2. Okay, and then I'm gonna start my server. All right, so it starts, let's say, okay, so the user's work, actually let me put this in a slightly nicer display. All right, so this browser has an add-on, has an extension that displays the JSON a bit easier. All right, so we have the users here. But then let's say I send a put command, for example. Let me get my command here to have a put command. So let's say we want to modify user 3. So right now it's Ronald McDonald with ID 3. Let's say we just want to change his phone number because it's wrong. So I'm gonna just modify this previous command I have. Okay, so this is how we do like a put command. So let's just say all ones for us to really see what's happening. So I'm sending a command to modify user/3, and I'm sending the payload of what we want to be modified. Send that, so that should be successful. And if we refresh, cool. So our changes was applied 111. The thing is, right now we have NodeMon set up. So whenever we change something in the database, the server would restart, and I actually want to show when it restarts. So let's say I don't know, I'll put a comment here, comment. So our server restarted. So and then we try to see if that's still there. So when you refresh, so not anymore. So the thing is, our data's not persisted to a database yet. It's just kind of saved in memory. Like this array is saved in memory, kind of an in-memory copy of the users.json that we have here. So yeah, so now the goal of this chapter is to just make sure that gets persisted to the database. Let me put this a bit bigger. So I hope you get to do this part, the MongoDB Atlas sign up, because you're gonna get a connection string there that we're gonna use it. If you still don't have it at this point, I could probably give you mine. So just message me on Slack if you really need it. But I think it's a bad idea to share connection strings like that. But just today, if you don't have. So quick intro to SQL versus no SQL. I know that some of you who are in Concordia, you might be more familiar with SQL. I did that whole course, databases. What was that? 353, and it's all SQL. I have never heard of no SQL in Concordia at all. So this concept might be new to you. So a little intro here. So in SQL, you have database, tables, and rows. You might have a data DB here. That's your database. You have a products table. You have some rows here on your table, and then you know that in SQL you have kind of a strict schema, right? You have defined columns like ID, name, brand, price, and they're actually very strict that you have data types for these things. You already know that brand should always be a string, price should always be I don't know, a float or something. So you define your schema. The schema is strict. In NoSQL, however, it's more loose. It's a loose schema. So we have database, collections, and documents. So you have, instead of a table, you have a collection. And instead of a row, you have documents. And each document is just a big, kind of a JavaScript object or a big object. And the schema is not strict. So you could kind of have some ad hoc stuff like this, color blue, which is not really in a schema. There's no schema somewhere. You could even, maybe here instead of a float, maybe here you put a string instead, something like that. You could add columns as you go, if you may. So it's very loose schema. Unstructured data, add fields as you go. Document oriented. They really look like JSON, which is a big advantage if you're a JavaScript developer. Either you're in the front end or back end. It just looks familiar. Apparently it's very good for if you do a lot of reads, because it's basically just a big hash. So theoretically it should be O of 1. If you don't know those terms, don't worry about it. Basically it's just fast for reading. And the thing is, you shouldn't use it every time. This is just kind of a FYI. There's a different kind of database structure. You should not use it when you need fancy queries, when you need fancy joins, like stuff like this. you know, because it doesn't have a structure, and it's also not ACID compliant, which has something to do with you know, if your database fails, how consistent with your data be, all of those things. It's a different kind of handling for Mongo, but just kind of a heads up on that. If you really need those things, you know, for example, for your company, you know, don't just slap on a no SQL database. You know, make sure you know what you're doing, and especially if you need more writes than reads, that's the time that maybe you need an SQL. Having said that, so we're gonna use a MongoDB Atlas cloud cluster, and then the best thing is it's free up to a certain use, and we're not gonna pass that limit for sure. So to get started, we're gonna have a MongoDB driver. So we're gonna install this thing, MongoDB, and like I said before, we're gonna have this env file. So we're gonna add that env file, and make sure you create an env file in your local, and then put your values in there. The most important value is the MongoDB connection string. So, and then put the string that you got from when you signed up to MongoDB Atlas. We're gonna need that for the database. So make sure you have that. So yeah, put it there, and then so whenever we add a new key in env, we also have to add it in config. Actually, let me go to my database branch. Oops, I changed something. Let me reset hard. Okay. All right, so whenever we change something in the env, we have to put in the config as well. This config, we did this in part 1 in chapter 3, so that's there's only one place to read our env file, and then we just expose that here as an export. So the big file for database that we have, the big code implementation that we have is the db.js. So I'm gonna spend more time to explain this part. So what's happening here? So I have the code on the right side, and I have kind of some explanation on the left side. So here, so first we have the config. So this is just to get our env, and then we're importing the library that we just installed, the Mongo client. This is our driver for the MongoDB database. We're creating a class here. So yeah, you could create class in JavaScript, and you could also kind of use them in an object-oriented way, but that's probably for a different workshop to get on the details with that. But so you could create a class, and here we're instantiating that class, and we're exporting just the instance. So the purpose of this is it's kind of like a singleton. If you've heard of design patterns, it's one of those really useful design patterns. It's a singleton, so that all of our code, or any code in our code base, any resource, don't have to recreate this instance. It's just created once and it's shared. So in that way, we kind of save on the resources. We don't have to keep doing it again and again. And the meat of that caching is here. So we're saving in the constructor. So if you did OOP programming, so this is the same concept. You have a constructor. That's where you initialize the things for your object instance. So here we have a DB attribute, DB member. Yeah, I haven't done OOP in a while, sorry. So we have this DB value for our object, and the first time it's not initialized yet, so it's gonna go to the else. So in the else, this is where we connect to our database, to our cloud database. So make sure when you do this, you connect it to the internet. But yeah, for sure you connect to the internet right now because you're watching a stream, so that shouldn't be a problem. And yeah, so we connect to the database. If it errors out, we send an error message. If it's succeeded, we connect to the database, and then we assign that database object to the instance of the class, so that it's saved for later. So this is one of those marvels of OOP, is that you could encapsulate things, and yeah, they're kind of inside, and then you save memory by doing that. So, and then we just call a success callback, passing that DB object. So the second time this thing is called, we already have this.db saved. It's already initialized, so we don't have to reinitialize again, because imagine every time someone uses this database, you have to connect every time. So that's a lot of wasted network calls for you, a lot of wasted resources. So we're saving that here, and then you just do success callback. And how do we use this thing? So we use that like this. So our primary example is the products resource. We have our CRUD routes for products. You could do get, post, products, and all of that. But now we're gonna put it in the database. So we import our class here, that class that I just talked about, and then we call that connect with callback method of it, and then that connect callback, it always returns. Oops, sorry, where's that? That connect callback, as we saw, it always gives to you the database. So here we pass a success callback that gets called by that class. So here we have a handle on a DB object, and then from the DB object we connect to our we use the collection that we need, which is products in this case, and then this is just some test code. So find would just get all the documents in that collection, and then convert that to an array, because the array originally it returns a cursor, but we don't really want to deal with all the cursory stuff like next and previous, so we just convert it to an array here, and then we log the result, and if something wrong happens, the failure callback would be called, and that should happen as soon as we start our server, because that's kind of in the main main execution line, right? It's not inside any route handler there. So if that works, so it's here. So whenever you restart your server, okay, I'm gonna restart it just. Right. So whenever you start a server, this thing gets logged. So this is the code that produces the log. So this is the products in our database. If you really want to check, on your side, you're paranoid that, oh, maybe that's not the thing in my database. So let me just connect. We can check quickly what's in our database. All right, so we go to products. Okay, so that's it. So this is our actual cloud database instance. So you see that it's the same. So that's good. That means we're actually connecting to the database and getting the data there. It's not hard coded or anything. Right. So let me just pause there for a bit. Okay. Any questions? All right. So that's good. So the database works. Phew, that works. Yeah. So if you got that to work, that's a big shout out. It's really connecting to a database. It's not straightforward. That's why I like these services like this. It's cloud. You just slap a string and you're connected to a database. You don't have to install anything. So it's really convenient. So we have a callback here. So we're using a callback, right? So we're passing a failure callback and a success callback and a failure callback. So we kind of want to modernize it a bit by making it a promise-based method instead. So how we make that promise-based is like this. So this is what we have right now. This is what we're gonna do after in the left side. So it's pretty much the same we have this logic here that if you're calling it for the first time, you connect to the database. If it's the second time that you're connecting, you don't have to because it's already saved. The only difference is now instead of having a callback here, we have a promise.resolve, and then here for this is a lot kind of a simpler. It's basically the same intent, promise.resolve, and returning a promise like this and then resolving it inside. It's just here we could do this easily, promise.resolve, because we already know that the database is good, because it was already saved in the class. Oh, sorry, in the instance of your object, technically. And here, we're returning a promise because, maybe, you have an error here somewhere. We can't promise resolve an error, or that would get messy. So we'd rather do the full syntax, return new promise, resolve or reject if, whatever happens to that connection. And we reject here if there's an error, and we resolve if it's good. Either way, the result is the same. We go to our consumer code. I mean the code that uses that database class. We connect with promise. No more callbacks. Since it returns a promise, we could attach to the then. What happens if it succeeds? So we have the DB object, same thing. You connect the collection. You do your logging here, and if you catch any errors. Cool. So should be same output as before, but let's try that out anyways. So we have 4.2 promise. Cool. So restarted, so we still have the same results. So nothing changed, but now we kind of made it a little bit better. We have a nice promise call here, a little bit cleaner than before. But we're gonna make it even better. One step further, we're gonna use async await. So async await. Right now we're gonna try to async await it from the consumer code, but we're gonna see after how we kind of structure that into our class. But this is kind of like the naive implementation of it. We could just, okay, we have a promise code here. Why don't we just make that async await in the consumer? So we could do something like this. You could wrap this whole code into an async function. Then inside you could await it, because this works because like I said before about async await, is just a syntactic sugar over promises. So you could do something. Sorry, you could do some async. You could do await on a promise, and then you achieve the same result. So you don't have to. The nice thing is you don't have to attach your then and catch here. You could just await it, and you can assure at this line here that it's already good. Let me just you could assure at this, when you get to this line, that worked, that you had the DB object. Then we do the logging here. The only caveat of that is now we kind of have to call it explicitly from somewhere, because we wrapped the function, we wrapped it in an async function. So let's try that. I think that should still work. Okay, it still worked. But now we have a nice async function here, but we actually have some problems here in this code, because right now our consumer code, meaning our product resource, it's doing too much. It's handling the database connection here by itself, and the problem with that is, what if we want to bring this same functionality into our, let's say, the user's resource or foods resource? That means you kind of have to copy paste that whole thing there, which is not ideal. We kind of want to modularize it and then put it in one place. And right now we're not maximizing the use of our class, because here every time we need to connect, we're reconnecting to our collection. So there's two things, right? We connect to our database, and then when we have a database object, we connect to our collection. We're already caching the database here, but we're not caching the collection yet. I mean, maybe we don't have to, but it's the same collection, right? So we could even optimize it further, and then we could also save this so that every time you don't have to call this every time. The collection would also be cached, and it would look like this, from this thing to the right to this thing to the left. See how much cleaner that is. You just go, okay, class, get me the products collection. I don't want to deal with objects. I don't want to deal with getting collections or something like that. I just give me the collection, and I'm gonna use it right away. It's a lot cleaner. This is what's gonna happen in our database class. We're gonna have a collections object here that would hold all of the different collections, one for products, one for foods, one for users. So that's gonna go like that, and then we're gonna have this asynchronous call. So we're just moving the asynchronous call from our consumer to our provider here, to our database class. It's the same code. The only addition is that instead of reinitializing the collection every time, we save it here. So we once we get the handle to the collection, we save it in our hash, and our hash is inside our object instance, so it would remain there. And the next time we call it, it would already be there, so we just return it, right? So that's kind of a neat way to optimize it. So let's just try to see if that works. There should be no change in kind of code, but so it still works. Let's try it again. Okay, it still works. Just now it's a lot cleaner, right? So in our consumer code, we just require the whole file, and then we just get the collection. Well, it's a lot cleaner than before. We don't have the consumer doesn't have to care about all those things. It's the classes that's doing all the work, and it should be, right? So that's one way of organizing the code. So cool. Little checkpoint here if you have any questions, or you need maybe a minute or two to kind of digest that information and then ask questions. I'm gonna just grab a water here. All right, so yeah, so that was just a little checkpoint. That's probably a minute, but I'll give you like maybe around 15 minutes when we get to the activity, if you're really itching for a break. All right, so and also if there's any questions in YouTube, I'll answer them when we go on break later. So don't worry. I see your questions there if you post any question in YouTube, but I'll answer them later during the break, and I'll probably answer them on Slack, so we have visibility for all of that for everyone. Right, so now that we have our nice collection class, we're gonna do the full thing. We're gonna convert all of our CRUD routes, post, get, put, delete. We're gonna convert it all to MongoDB. What I mean is that before, we're actually doing a lot of work manipulating our in-memory array. When someone, let's say someone sends a put request to update a product, we're trying to find the product, so we iterate through that array, and if we find it, we replace it. We do all the ES6 stuff here, all of those things. So now it's going to be a little bit easier because we're going to offload that processing to our database. We don't have to do all that array manipulation anymore. We just send the request to the database, to our Cloud DB, and then it would return us the response. So this is how it would look like, kind of just a mapping of that for the MongoDB commands: insert, find. It's pretty much straightforward. The most important thing, before I kind of go autopilot on these things because it's really pretty straightforward. The most important thing is that we make our route handler asynchronous. So remember what we did before here. So now we have this nice collection. We have a collection object for our product, but where do we put it? Like where do we put it? We can actually put that inside inside our handlers like this, right? And then we could use that. That's the ideal way, because if we don't make our route handlers async, we're gonna have to do something like this. So after getting the collection, we have to connect a promise, and then the whole routes would go here. So to show you what I mean, it would look something like this. If we do it like the promise way, right? Collection, and then all of our routes here. Okay, I'm gonna undo this after, but just to show. So we're gonna do something like that, and then now we kind of have this. I know it works, but it's kind of weird and nested in a way, and then we do our collection there, blah blah blah. So it's not ideal, right? Because you kind of had this whole thing nested somewhere. The nice thing with async await is we could instead of doing that, we can make our route handlers async, and that's supported by Node. Thank goodness that's supported by Node. So we could just do something like this, and then you do collection.find blah blah, and then you could return the products. So that's that whole rationale of that. That's what we're doing here. So it's just a lot easy, just a lot easier, in our route handler. When the client requests /products, we get our collection here from that thing that we did before. We do await for that because that's asynchronous, and then we do also await the to array because that's also asynchronous. The nice thing is we could await all these things, and then we do we just return the products. Perfect. And that should be the result, right? So let's actually try it out in the first one, because the next ones are gonna be pretty much straightforward. But let me just reset my oops, sorry. Oops, sorry, I kind of messed up my editor there. Sorry about that. All right, so right, so first thing that we made async, or the first route that we converted to our database logic is the get products route. So you had that here, and so let's try it. Let's try it. Let's use a curl this time. Curl. By the way, for the ones who are wondering how I changed my terminal from the part one. I'm on a Mac now, and I'm using this thing called Fish. It's pretty cool because it kind of saves your commands, something like that. So you could ask me after on the whole setup. Okay, so cool. So that works. That's from the database. Just a side note on the database items. You can also see that it's from the database if you get this really long ID. It's an internal ID used by MongoDB. It's kind of a universal ID, or UUID if you're familiar with those things. So we know that it's from the database. So that worked, and now we're just gonna convert all of them into that logic. Products ID, so getting one product by passing a parameter. So we did this in chapter 2. When the user goes /product/2 or something, we get the number 2 here, or whatever ID it was passed, we convert it to a number, and then we use that in our queries. So in MongoDB syntax, we do find one, and then we pass the query, but the query is an object. So you could have more things in the query here. Like let's say you're looking for a particular product with ID and name and all of that, so you could do that here, but here we're just concerned with ID because that's the parameter that we provided there. So it should work like that. So quick test for that one, and then I'm just gonna go straight to the curl, right? So that works. So we did that there. For the post, put and delete, I'm gonna like run through the material, and then we're gonna test it out at once, to make it faster for the switching from material to the code. So for post, we had this logic before already for like if the product is already found, you're trying to create a new product but it's already there, so it's gonna error out. Same thing here. Once we establish that the product is, I was talking about the product ID. It should always be there. Once we establish that the product passed as an ID, so we do our connection here. We try to find the product first, because if the product already exists, that's an error. We want to make sure that there's no duplicates, and our ID is kind of like our identifier here for the products. So if the product is not found, that means it's a new one. We insert it to the database using insert one. So that's the Mongo syntax for creating a new creating a new document. And here we use ES6 spread here. For those who don't know ES6, sorry about that. I discussed some of this already in part 1, but here we call it spreading. We just taking all the attributes of that product into this thing, kind of flattening it. We're flattening the object here so that we could add something new. Instead of just doing insert one new product, because we want to add a new attribute here, we're exploding that object. We're getting all these attributes so we can add something new here. So we just kind of add kind of an audit field created ads. So that should work. You post a new product, it should be added to the database. For the put, it's the edit. We want to update a product, and for that we have to pass an ID parameter, because you have to reference, of course, the product that you want to edit. Same thing, we try to find it here using find one. If it's not found, we're gonna error out. But if it's found, we update it. The syntax for update is update one. And how it works is you pass the query for the product that you want to update. In this case, it's the ID, so we want to update the product with this ID. And whatever we want to update in terms of attributes in that product, we do like this. So this is a MongoDB specific variable $set. You do $set, and then the value of that is the object of all the attributes that we want to override. We want to overwrite in the object. So an example here, let's say you have the product tree. You want to update the price. So if that works, it should update the price of that product. Anyways, we're gonna see that after, because we're gonna do a mass testing for create, edit, and delete. And lastly, for delete, once again, for delete, you have to pass the ID of the product you want to delete. We try to find it here, and then if it's found, we just do delete one. Yeah, plain and simple, delete one. You pass the query of the item you want to delete. So let's do some quick tests here. I'm gonna pull the branch, the last one. So we have the create, edit, and delete, so it's all there. So we're gonna do some tests here. First of all, we want to see all the products. So like that, actually we can see here too. See there. So let's test the create. So right now we have 2 products. So let's say we're gonna create a new one. So we do post, right? So we're creating a post. We don't have an ID tree yet, so that would work. Right, that worked. Refresh, so it's added there. So the post succeeded. Now let's say you want to edit it. So let's change the price of that. You know, inflation or COVID, whatever caused all the products being so expensive nowadays. We have to update our database, of course. So $4.99, so that's good. We're referencing the product with an ID tree there, and that's the payload that we want to update. Cool, that works. See, that's $4.99, and we also appended that the audit field there. See the updated ads. And the other thing that I want to show with put, how we're handling it, is that it overrides the fields that are not there, but you could also add a new field, because we're taking the whole object and kind of just slapping it into the old object, and the attributes that are there before, like the price, would be updated, but the attributes that are not there before would be added. So that's kind of the neat things with JavaScript. So let's see, let's do another inflation here, but let's just add I don't know, picture. Let's see if my terminal supports emoji. Oh, it doesn't want to. There we go. Oh, come on, rice. Oh, it really doesn't want emoji. Okay, whatever. Okay, so just put rice there. You know, so we're adding a new attribute there, so our put would also work that way. So there you go, we added it. So that's the nice thing with put. And then lastly, let's delete it. I think I could just get by with typing it. So we could delete products /tree. So take a good look at this one, because that's gonna be gone. Bye bye. All right, so that's gone. So the delete worked, and that's it for the database. So if you want to check the contents of the database, you know, just log into your MongoDB Atlas. You could even manipulate it here, of course, but just for checking, you know, you should kind of do it for the with a curl, you know, to make sure that the server works. Yeah. So this is an activity point. So I'm gonna give you like around 15 minutes. Try them out. If you have any question, ask me, but on Slack. But I kind of also want to know if the instructions are clear enough, so that you could do them. So yeah, I'm gonna leave you to it. I'll see you in 15 minutes. All right, so welcome back. I posted 2 questions on the Slack channel there. So if you're in Slack, just answer one of them since I want to know, if for to allow me to readjust on those things. Cool. So before we move on to the next chapter, I just want to show quickly the solutions, but it's all here. So, and the nice thing here with GitHub Compare is that you could just compare 2 branches like that, and you could also change it here. So that's super useful when you're using GitHub. So we deleted the foods.json. We don't need them anymore because we connect to the database. We don't need that local copy of that data. We also deleted users.json. I think it's pretty much the same change here. So it's really just porting whatever we did on products into these 2 resources, foods and users. So all of those things, making sure it's async right there. Yeah, if there's anything that I didn't cover, just let me know on Slack and we could discuss maybe in the next break or at the end. Okay, so let's so a little review what we did. So this is how we connected to the database, but we really took our long way to get here because we had a callback based class, then we had a promise based, and then we ended up with a sync await that just looks a lot cleaner like that. So this is all the syntax you need for MongoDB CRUD, but as long as you have the collection, you could explore that. You could just also go to the MongoDB API page to see all the other options they have. All right, so let's continue on chapter 5, building the CRUD. So now that we have our REST APIs connected to the database, we're all good in terms of data, but now it's pretty still primitive that we're using curl to send requests. It's perfectly fine that we have a REST API for more of the text-based user, but now we're gonna see how we could have a server rendered app or a server rendered site with Node. So it's gonna look like that. A little preview. So we'll be able to see all the users, edit a user, delete a user, create a new user. Right, so all kind of the CRUD management, but with a nice UI right there. A little side note here on static websites versus dynamic websites. It can get like a bit confusing, all of these different terms, but one thing I can tell you is that static websites or static rendered websites, this is what we're gonna do after. It's really the server doing all the rendering. Like right now, everything is, our views are HTML. There's no JavaScript in there that's doing some rendering. When you have JavaScript doing the rendering and stuff like that, that's when you go into more a dynamic website, or you could also go further into what they call a SPA or a SPA, single page application. This is when you start to use front-end frameworks, React, Angular, Vue, something else. You might even just use vanilla, but that's kind of the main difference. And then we have the Jamstack, that's kind of in the middle. You have static site generators like Gatsby. You still use React, but the output is server-side rendered stuff. The advantage of server-side rendered sites or static sites is it's really fast because you're delivering just HTML. Everything's already processed in the backend. Compared to dynamic website, there's sometimes there's an initial lag there because you're downloading a lot of JavaScript, and then your JavaScript still has to render a lot of things on the front end. So yeah, so here we're gonna do a static website or server rendered site. So we're gonna use something called a template engine because right now we're just using HTML. It's pretty pretty basic that's the HTML. But what if you want to inject like variables into your HTML, or let's say we want some reusable pages like a header, a header you don't want to keep copy pasting into all your HTMLs. You're gonna need a template engine for that, and that's what a template engine is. We're gonna use EJS, but there's a lot of templating engine for nodes. You could look them up. It's kind of like PHP if you did PHP before, or JSP, or ERB, or Ruby HTML. If you did all those things, it's pretty similar. Even I think that it's very similar to PHP. I remember PHP from Concordia, my first web course. So in 287, I think we did something like this. PHP. That's how you do variables. You do conditionals like that. You evaluate variables like that. You can use loops like that. There's a lot of other syntax. I wouldn't go through all of them. You could explore them, but you're gonna see the ones that we'll need for this chapter. And you could have a reusable part like a header, and then you could include them like that. So it would just magically go in there, all the HTML, once it's processed. So we're gonna install EJS for this chapter. It's kind of a server config, but we have to set the view engine to EJS. This is really node specific. And server set also allows you to set some server stuff like environment and stuff like that, environment variables too. You could check that out in the Node API. But the first thing we want to do is to rename or change the extension of all of our HTML views, like right here, they're HTML. We want to change them to EJS so they get processed by EJS. So actually, let's do that. Git check out 5.1. Cool. So we renamed them. The nice thing with EJS is you could still keep your HTML. You don't have to change any syntax. You're still writing HTML, but you could add some variables and stuff. So that's a nice thing. The other change here is that instead of using send file, we're using render now. So before, on our page route handlers, we were doing like a send HTML something. Now we could use render, and render knows to look at your views folder. So if you have an about.ejs here, your render just have to say res.render about, and you don't even have to put the extension .ejs. It knows that it's here in your views folder. So that's a nice thing. So yeah, that's what I mentioned. We don't need the send file anymore. It's more cleaner res.render index. As long as it's in your views folder, it's good. It finds it. Same thing with that. Static assets. So there's just this concept of static assets in web development, which pretty much everything else other than your server code, style sheets, JavaScript files, images, they all go into the public folder. That's just like the standard folder where you should put your static files. So here we're gonna add one of our static files, CSS style sheet. It's gonna go on public. So right now our public's gonna look like this. So we have our style sheet there, and if you have images, it also goes there. You could have different structures there. We have to expose the public, because the thing with servers is that once this gets deployed to somewhere in the cloud, it's gonna be deployed in a computer somewhere, right? It's just a computer, or you call it a virtual machine or something else, but it's gonna be in a computer somewhere, and you want that computer to be secure, because you don't want anyone to just go to that computer and start deleting your HTML pages or your CSS files or do whatever. So the security default is to kind of block the access first, like block everything and just allow things that we actually need. So right now, if I go to even in our local host, we could kind of see this behavior. you know, oops. Okay, I'm gonna have to do npm install. Sorry about that, because I switched to a later. All right, I switched to a later branch. Npm start. So if I go here and let's say, is this gonna work? Like if I do styles, .css, yeah, it does work. Cool. All right. So because it's in public, you know, it is exposed because we actually added that here, right? We added this public folder to be exposed to the public. But let's say, you know, you want to test the security of this thing, you want to see your config.js, for example. Yes. So you can't get config.js because you don't have a route for that one, and also because even if you do, you know, you kind of have to go through hoops to expose a server file there because it's secured. Basically, you can't expose to the public any of the files here. You also don't want to, and anything that you want to expose, put in the public, and make sure to expose it here. So it's called express static. So that's how you do. If you have other folders you want to expose, put it there. But by standard, just put it in public. It should be available, like what we did before, right? So it's available there. Cool. So now that we have that, now that we have EJS, we're gonna start to write EJS files for our views. A little note on the structure here. So we have routes and views, right? That's our folder structure. So the routes for views like this, it's gonna be rendered by these route handlers inside index.js. And then, for example, the EJS pages for products, it's going to be rendered by products.js and so on. So we have just a reminder on that structure. We have, once again, pages, that's for our EJS views, and then API, that's for our REST API. So there's a distinction there, right, between web pages and REST API. The web pages, it's HTML or EJS, and then the REST API, it just returns JSON. So some kind of a planning stuff here. A little side note on the index. So what is index? Why do we call it index? So index became kind of a, you know, this homepage of a website. So once you go to a website, you expect that the slash routes would go to index.html, right? And that became kind of the standard. And here we're adapting that too, such that, let's say you have we don't have it right now, but we're gonna have it after. Let's say you have a resource like users. We also use index.js to put the homepage for that resource, instead of having this, which is kind of really awkward, users/users.js. We use index.js, kind of like that's like the standard way of doing it. And yeah, so let's actually see how that structure looks like. All right, so see, we have our EJS pages here. Let me close the other stuff. So you have users, edit, index. So our index, that would show that homepage that you saw before, with the buttons and the list of the users. That goes to index. And we have, you know, we have some variables there that we interpolate. But first we have to create the route handler that renders that page. So the users, the client, have to request that page first. So here we have a new route called /page/users, kind of just to organize things. We have that route, and then for that route, get the users, you know, using our database, and then we render it on the EJS view, which is on users/index. So it's this one. We render that there, and we pass the users variable. So when we pass the users variable, it can then be used by that view. So here, when we end up rendering it, the users would be available because we passed it from here. See, so and then from the users, that's an array, so we could do for each. That's EJS syntax. Then you could show all of that. Same thing for new. It's just establishing a route for that. When users go to slash new, you render the new page, which is empty right now, but we're gonna write that after. For the edit, we kind of need an intermediary page. So when users go to edits, we don't we show the edit page, right? But the user have to specify which user they want to edit, and then when we get that, we render the edit page, which would go here. Once again, it's still empty. And then for us to be able to show a form that that shows that user, actually let me try that here just to make it clear. Okay, that's our page user, and for the edits, we don't have the edit here yet, but we're gonna see it after. Go to tree maybe. Okay, we still don't have. Okay, well, anyways, we're gonna write it, but for that edit page to be able to display a form and then show the current user's name, email, stuff like that, we have to pass it to the view. So we pass the view like that, so that the view has access to that. And lastly, we're gonna have a detail page in the show.ejs. Same thing, we pass the user. And then all of those routes that we set up for the user views, which is here, we have to make sure that we mount that in our server, right? So we import that and mount it in the server for them to work. Yeah, so it's not really doing anything now, but just got to kind of confirm that the route's there. It's still empty right now. We're gonna write that after. So we're gonna write them one by one. First, we're gonna write the index.ejs. So let's go to tree. So page users. Oops. I must have something there that is not defined. Yeah. So okay, I have this thing here. I'm gonna explain that library after method override, but let me just install it so I can start my server. All right. Okay, so that's how it would look like. Actually, let me put this somewhere else so we can still see the content. All right, so we have our new user. Nothing yet, but this is the index. So on the index, we want to show a list of the user, and then for each user, we want to display two buttons there, edit and delete. So this is the code for that. I won't go into the details of the EJS, but you could kind of read, see from the code intuitively what it does. For the edit button, we have a link. We're using a link. It's just styled as a button. We use Bootstrap. Yeah, the Bootstrap is actually there in the link in the head, and then we have our own style. And then for the delete, since we're sending an API request directly, we're using a form. So one way to send a request directly from a web page for create, post, and delete is to use a form, because like edit, it would work right away because it's a GET request, right? Because we have a link directly. I could also just copy paste that link and it would load. But the problem with create, post, put, and delete is that it's an actual request that we have to do to the server. You can't just load a post request, for example. You can only load a GET request. So that's why we have to submit a form here. And and then that form is sending a post method, which is kind of strange because it's a delete, right? But I'm gonna explain shortly what we're doing there. What do we have here? Okay, so we're just displaying that. So what's happening here is that HTML forms don't allow put and delete requests. So HTML forms don't allow put and delete requests. They only allow post. So I put a little link here on why it's not supported, but like right here, what are the details on that? But so we have a workaround on doing that. We use a thing called method override, so that here we're sending a post, but by putting this in the action part, we override the method. Instead of post, we make it a delete. It's kind of hacky, but this is kind of our best bet now for doing this. That's really clean. Instead of putting all of our create, delete, edit in under post. So that's our workaround for that. That's why we install that thing called method override. So I'm not gonna try that yet because I think we have more notes here. Okay, so yeah, we just render edit for that, and then the deletes there. So yeah, method override. So yeah, let's try it out. We could only do the delete for now, but because we didn't write the edit yet. But let's say I'm gonna delete this guy here, registered user. Okay, so you could see that it was deleted. It was registered user 2. Actually, let's try another one. So I'm gonna delete this one, registered user 1. Right. See, now it's gone. It redirects to like a page that's supposed to be for REST API, but we're gonna fix that after. All right. So that's for delete. Now we're gonna write the create page, which is this one. That's 5.4. So for the create, it's pretty much the same form, but here it's more straightforward because HTML forms natively support post command, post request. So here it's pretty much a standard HTML form. You have a post that goes to /users. So that request goes to our API, which is here. So whenever the user click that form here, so we have the form. When the user clicks submit, it would submit the form. So it would go here in route and post. Sorry, that's in users. So it would go here, router post users, and then the way it works is that we're using the name attribute of the input, so it's HTML name attribute, so that these inputs will be mapped to the object, so that when they get submitted here in a route handler, the request.body would contain name, email, phone. So make sure that each input is referenced correctly. So yeah, that's basically that. So when we submit the input, it would go to the request.body as part of that object, as this object here, user. All right, yeah, so that's, in other words, a little explanation there. Then there's another thing here that's that we did. It's a body parser thing. If we don't have body parser, we wouldn't be able to read the request here. And we could do that in plain Node, but this just makes it easier. And since we already have a body parser in our server, we're using it for the JSON stuff. We just have to add the URL encoded, because forms, HTML forms submitted, that's URL encoded data. So just make sure you add it there so that when you submit your form, it would go through. So let's try that. Okay, so All right, so let's just say user 5. I don't think I have user 5 yet. 1, 2, 3. Really lazy. Okay, so it got added. So that means our body parser worked. If you want to debug that part, feel free. I added VS Code debugging somewhere in the document. If you don't find it, just ask me after. But yeah, so that's for create. For edit, it's pretty much the same. Let me just pull that code. It's pretty much the same for the edits, but here, like I said before, put is not supported natively by HTML forms, so we have to do a hack there. Method override, so the request goes to our API in the put, but it's still the same mechanics that we had before. The attributes are mapped so that in your route handler, request.body contains the name, the email, and the phone. The edits, those edits that we want, and then here we updated user, goes there. We saw this before in MongoDB. Yeah, just a little note on the method override there. Let's try this out. So let's go back to page users. So let's say let's edit the user 5. We want to make it a different number. So that succeeded. Okay, that succeeded. Yeah, I have to go back and forth. Sorry, we're gonna fix that right after. So that's it for the CRUD routes. It works. We just have this one bug that it instead of going back to the index page, it goes somewhere else. It goes here. Let me see any questions. Okay, cool. So I'm gonna continue. So the reason that this is happening is that these requests, the post, the put, and delete, they go where? They go to our REST API handlers. So they go here and post, they go here and put, they go here and delete. But if we see what's happening there, we're actually just returning JSON when it succeeded. That's why it's not rendering the index page that we want, is because we're actually not rendering the index page. We only render the index page when the user goes to our page routes, which is here. So remember before that we have two functions for our server. One is for the REST API that does this CRUD stuff but only returns JSON, and we have the web server stuff. Our server is serving web pages, so we want to be able to render things. But now that we kind of mixed them up, we have to do some manipulation. And what we're gonna do here is that we're gonna try to detect if the client that requested that sent the request to our API is a browser. If it's a browser, we redirect them to the index. So it sounds simple, but it's actually quite tricky because we have to check browser request headers. So once again, that's our server's two roles: web server that serves HTML. These are the browsers clients, and the REST API, these are the curl clients. So we have to check the browser request headers and the user agent. So here we can actually see that quickly. If I go to my network and then I refresh, so I could see in the request here that the request header, HTML, so that's a browser requesting stuff, and you can see the user agent here as a Mozilla. So for our purpose, that's enough to check. So if we see here that there's an HTML and then there's a Mozilla here, okay, that's a browser. Redirect the user to the index. If not, that means it's curl. So user agent is curl or whatever it is. We're just detecting the case that it's a browser. Everything else, it's going to be a REST API thing. So the code looks like this. We're checking the request headers. So if you don't remember what request headers are, we discussed them, I think, at chapter 2. So request headers is this header sent by the client when along with the request. If the accept, this part contains HTML, and the user agent is Mozilla, so we direct them to user. So Express has this nice redirect feature. We direct them to slash page slash user. If not, we kind of just blanket everything. Okay, if it's not a browser, it's just whatever, just return JSON. It must be a curl client or a script that just wants data, that doesn't want an HTML page. And then we replace all of our rest.json there, and in those routes with that method, redirect to index or return JSON. And it looks like this. Okay, I pulled that. So now let's try it out. I'm gonna keep the dev tools open so we could kind of inspect that. So let's say we edit this instead of 444.3. Cool. So now we were able to redirect, and you can see from the request here that was sent to the server, we have the method override, but we were able to check the request headers here, and then the user agent here, that check went here, right? Because we're calling it for each route handler. So that was called for put, for example, for our edit. So that was called here, and then yeah, since it was able to detect the request, it was from a browser, that then it redirected. But let's test that for curl. That means our method should be able to identify between browser and non-browser, and here it should detect that it's a non-browser. So let's send a curl command here. Okay, curl delete users, this guy here. I don't, oh, okay, sorry, I think it's user 5, right? Okay, actually, yeah, let's just curl all the users, because the thing is I'm not seeing the ID for the user that I want to delete. So I want to see first. Okay, so the user I want to delete is user 5 with ID 7. There we go. So that's what I wanted to do. Sorry for that. Users/7. Okay, cool. So that worked because we didn't get a redirect here. We actually got the JSON users. If it was a redirect, it would look like you know, you have been redirected, and then you get maybe a bunch of HTML here. So that worked. Cool. Again, it's a bit hacky in a way. You know, in production environments at your work, you know, don't just do that right away. There's different ways to handle this kind of problem. But what I wanted to show here is that you could do browser and user agent detection, and it might be useful in some cases. For example, in Rails, it's a different framework. For web, they actually it's very simple to do, and you don't have to even do user agent detection. The really right approach is to keep the HTML and JSON routes separate for a resource. So what that means is that, okay, you know, we don't want to do this detection. You're gonna have separate for your you know, separate routes. So basically you might have /API/users/page/users, something like that. But yeah, so, and lastly, I think this is the last for this chapter, EJS partials. So right now, if we go to our users views, you can see there's a lot of copy paste going on here. You know, yeah, that's your index page, that's your new page, that's your show page. Show is not even there yet. That's your edit page, and you know, they're kind of all similar, right? Because we just need basically the bootstrap to work. The bootstrap styles, and maybe some of our styles. So we just want to make sure that it's included in every page. But you know, we're copy pasting it here, and copy pasting leads to copy pasta a lot of the time, so we don't want to do that. We're gonna have typos at some point, and if you want to edit that, you have to edit it in 4 places. That's the worst. So you want to have it in one place. So the solution of EJS is to have partials. So we're gonna have this partial heads that would contain all of those head stuff in your HTML, and we just include them. Very neat. So we include that. They're underscored prefixed because that's a convention. If you're doing a partial, it indicates right away that let's actually, if you're doing a partial, it's an indication that it indicates right away for someone who looks at the code, oh, that's a partial. That means it's not delivered directly. It's being included somewhere or being processed somewhere. So that's a convention that's used. So yeah, make sure you just import that, this underscore head EJS, see, like that. So include, and you reference that. And now our directory structure looks like this. So we have our views there, we have our users there, we have partials, and you might guess that the activity would just revolve on doing all of this: edit, index, new, and show in for our other resources, which is the foods and the products. And actually there's other stuff here. There's some really nice code debugging here, and I don't want to spoil it, but like here we kind of have this whole scenario. Oh, there's some bugs here, so try to fix the bugs. So all right, so I'll give you, I think we agreed on 15 minutes, right? Okay, it's not too much time. 15 minutes is good. So all right, I'll see you in 15 minutes. All right, welcome back. So, yeah, I noticed that we don't really have a lot of time. So I would kind of just focus on the kind of the more fun parts of explaining the solution. So for the bugs, uh, the emoji pictures are missing here. So what we're missing here is the food picture. So we put the other variables of that object, but we just forgot to put the food picture. That's the bug there. For the edit page, what's wrong with the edit? Yeah, so for the edit page, instead of it going to put, it was going to post. So now instead of editing it, you're actually creating a new one. So that was that bug. So just put the method override, and that works. And then create page. What's wrong with that one? Food's not new. Oh yeah, for this one, it's the input. The input didn't have the name attribute, so it didn't get sent to the backend. So that when it was created, it didn't have the price in the picture, just the name. So just for your inputs, make sure it's properly referenced. And the detail page, we have. Oh yeah, this is more just the styling. So make sure you put the include there. I'll let you explore the other parts. So we'll have more time with this chapter. So chapter 6, security. So far, we don't have any authentication here. As you can see, you don't have login, logout. That's the whole preview. But the scenario that we're gonna do, it's a pretty much common. You do this every day with all the services you do or social media. You register for an account, then you use your credentials to log in. If it fails, you redirect you to log in. If it passes, you get access to that gated resource. So we use the term gated here, or authenticated, to that resource that kind of restricted only to known users to that server, or in other words, to users who are registered. So basically what we did here is we have a registration page for user to register. So you had that whole form here. Notice that we put them in a different folder, in an auth folder inside views, and same thing with the route handler. It's inside auth to kind of the route handler is inside auth, so it's kind of separate from the rest of the app. Let me pull that out quickly. So it's all here: routes, auth, index, registers here, logins here. And for the register and login, they're both post routes, because we're submitting some information there. We can't really submit it through a get route. So HTML form, we're sending the data from this form to the register, and they referenced each one there, so they arrive here in the register. And we do some kind of checks here. If the user already exists, then we error out. If one of the forms fields are not given, like username, password, confirm password, all those things, the password and the combination don't match, things like that. Once we have everything we need, we end up registering the new user. We're doing a little trick here for the confirm password, because we don't really want to save the confirm password to the database. Confirm password is just a repetition of the password, right? So we're taking it out using a spread, ES6 spread. I'll have an example of that later, but once we have all the data from the form, from request.body, with all those checks, we spread the new user here without the confirm password, and then we just attach an ID and then create an ad, and then we direct them to log in, because so that users can log in and quickly log in. Pretty much post to that login endpoint. We submit the username, password, and the nice thing is when you have this is an HTML5 thing. I think when you have a typed password, it wouldn't show it wouldn't show the password as you type it. It's gonna be hidden. So let's see that. Yeah, so like right there, you know, it's not shown. And in terms of the routes, that's what I showed before. We do a little bit of validation there if those things are submitted. And for the login, this is where the authentication happens. Sorry, I'm switching from the material to the code, but they're the same at this point. So for the login, we just check if both are given. We error out if one of them are not given. If they're both given, we try to find that username from the database using username password, and then if we find it, we successfully log in, and then if not, login failed. Let's try this flow right now. But a little side note here for the what I want to say about the confirm password that we're taking it out. It's like this, you know, you have a dog with name, age, owner. You just want to take out the owner. You don't want the owner anymore. You just want the dog. You do ... copy, so that remains, but the owner kind of just disappears into thin air, and then that's it. Your copy is like that. So that's an example of that. And then yeah, so server, we imported the whole router for the auth, and then we mount it in the server. We did this before. And for the resource, for the gated resource, we're just using this is just one of the foods pages. Kind of it's really similar, but we're gonna restrict access to it after. We could see that here router gets a resource, but it's not restricted yet. But let's try to see what happens in the registration flow first. Okay, oops, register. All right, so let's say user 6, right? We want to really bad password choices here. Don't do this at home. Also, don't do this at home. This is just for demo. Okay, submit. That goes to the database. We could confirm that here. Registering new user. We log that in here. So it's all good. And then we log in. What was it? U6. Password done. Successful login. If you try to log in with, you know, just a random user, you should get a login failed. So that's good, but right now we're not restricting access to the resource yet. You could still access you know, well, we logged in, but let's say put an incognito window, anyone has free access to that, so it's not gated yet. So we're gonna do that after. But before that, I just want to show something really bad that we're doing with this with our registration, that we're just, you know, saving the whole hash like that, the submitted password, and in our database it would look like that actually. So let's refresh. This is our database view. See our user 6, it's plain text. It's saved as plain text. It's just a no in terms of security. You know, it's really bad. We shouldn't save anything in plain text. If someone's just looking over your shoulder, they would know your password already. So that's bad. So what we do is we hash it, and what we're doing is we're doing a one-way hash, and it pretty much works like this. So during sign up or registration, let's say this is the user password. He gave ABCD1234. We run that through a one-way hash that generates kind of an unreadable cryptographic hash like this, and we save that to the database. But what makes it really secure is that we add salt for the randomness, so that, you know, during login, this is the correct user, correct password, ABCD1234, because the server knows that cryptographic hash in the salt, this would pass, right? Because we would get the same hash as here. And then on the other hand, if the password is incorrect, as you know, it would generate a different hash, so it's not going to be equal. But what makes it secure is that, let's say an attacker is just trying to brute force guess passwords and stuff like that. because the attacker don't have access to our salt in the server, even if he has the same password as the user ABCD1234, it would generate a different hash. So some hash, and it would not be equal to the one saved in the database. So that's the whole concept of one-way hash. You could kind of like look this up. It's pretty much impossible to get the password from hash, and it's called one-way because we cannot decode the hash back into the plain text. We cannot decode the cryptographic hash into the plain text. So how we do it is we save the hash, and when the user logs in, we hash whatever username the user gave, and then if it's equal, that means it's good. So that's how we implement it. We salt it 10 rounds, which is pretty much very dramatic. For this case, it's gonna be literally impossible to guess, but we use a library for that, bcrypt, and then we hash the password and the salt, and then we save the password hash in the database so that we don't save it as plain text, right? And that's for the registration part. And for the login, we use bcrypt compare. This is where it compares the password given by the user to the password saved in the database, and it does the whole salting and stuff like that, the whole hash. And if it's a match, we let the user in. If it's not a match, login failed, basically. So let's try that out quickly. Okay, we had this. So oops, the thing is not installed yet, so I have to install that. npm install, npm start. Okay, let's register again, and let's see if it's saved in a database, not in plain text, right? That's what we wanted. U7 at sample.com. Okay, I just want that. All right, so save the database. Okay, so now we have this cryptographic hash, and this is pretty much impossible to decode this back into whatever password I gave, which is ABCD1234. Spoiler alert. But the nice thing is that when the user logs in, the hashing is done. Let's say I type a wrong password, login failed, and you can see here I'm just logging it for example, but you shouldn't log things like that. And if it's a match, it's gonna allow us login successful. So that's the hash there. So that's for bcrypt. But right now we still have a problem, right? Because okay, users log in, we could go to resource, but then again, if we go to a new browser window, it's still free for all. User don't have to log in to access resource, but we implemented the login part. So the big question here is how does the server know which user is logged in, or how does the server track that? It's kind of a weird problem because the server and clients are different. HTTP is stateless, but how does the server track if it's stateless? What allows the server to kind of like save this information for our user that's logged in? It's by session, and mind you, it's by session, because if I have a window here and I have another window here, they're different sessions. So it's not just user based, it's user per browser window based, and this because if you log in a Gmail and this window, if you go to that other window, you're not logged in Gmail yet, you have to log in again, right? So these things are browser window based. So drum roll, the solution is sessions and cookies. And you've heard of this, the words thrown around. I know it probably sounds like a how how do you call it? Anyways, really, you know, one of those buzzwords that gets thrown around a lot, and if you're not used to these things, it might be really confusing. But basically, session and cookies is the way to keep track of the logins and basically anything about the user. So session is in the server, cookie is in the client. That's it. If you get asked by the interview, if you know that, I think you're in a pretty good state already. Session is in the server, cookies is in the client. And how it works is that after the user authenticates, I have a thing like that here. Once the user successfully logs in, you know, in the post login, and then the server creates a session. That's on the server side, and then the server sends some session information as a cookie, and then the server does this with a response header called set cookie. This is a response header, and the browser knows what to do with that. The browser knows that when it sees a set cookie, oh, the server sent me a cookie. I'm gonna save it here in the browser, and then since it's saved in the browser, every time you send a request to the server in that browser window, it's gonna get sent along for every request. The cookie is sent along, and then the only thing the server has to do is check if the cookie is valid, is it expired, is it from this server, and we verify that it's from this server because of signatures. That's our secret key, and that's it. If it's good, we grant access. Yeah, so a little, you know, you hear cookies. They're very controversial because, you know, they use it to spy on our surfing habits, and I invite you to just, in any browser you are right now, just go to DevTools, go to Applications, go to Cookies, and, you know, see all these things that the websites are saving on you. Yeah, it doesn't matter where you which website you go, there's gonna be some cookies there, you know. So yeah, I invite you to do that, especially if you're opening a lot of like social media tabs, or you're shopping online. Just observe those cookies. You're gonna have tons, and that gives you an idea on how much information they have on us. So but that's more for a different point. Here we're using cookies for a good reason. We want to track logins, right? So we're the good guys here. So yeah, so first thing, we just have to make sure that we have a secret key, because the secret is used for signing the cookie, and what we have to sign it so that when it comes back to the server can verify that it came from this server. So whenever we add a env, we did this before. Whenever we add a secret in the env, we have to add in the config, and we're gonna use this little thing called cookie session. It's a very basic implementation. We configure it here, session, and then we set our secret here from the env, and this is very important, this part, HTTP only, so that this is another security thing, so that JavaScript, any JavaScript code cannot access document.cookie. Only requests can access those cookies, and it's very important, HTTP only. So it's secured because there is a signature. So, and then when so what happens is when the user logs in successfully, we create a new session, right? With that diagram before, we create a new session. We call login user here. You can call it anything, and then we put that information there inside the session, and this whole payload becomes the cookie later. So try to remember what's in here. It's the ID and username. Don't put anything sensitive here, because, you know, as you can see, it's so easy to see cookies. You're gonna see that, so don't put any sensitive information there, and redirect to the resource. So we're gonna try it out. Session-based authentication. So we have our little browser here. Oops, I think I have another uninstalled package. Yeah, next time I should really just install all of it at once, right? Keys required, so we need that key. So when you're doing this on your own, just make sure you have the key, because it's gonna bug you later. So You can use any key, but just make sure you have the secret key there. And usually when you put something in your env, you have to restart the actual server, not just let nodemon restart it. So we're gonna inspect that right now. So right now I am, these are the cookies at the server. There's nothing, right? So I'm gonna log in as an actual user. I registered already before. When I submit, boom, the server authenticated. That's just the hashing stuff before, but this thing actually ran successfully because we have the cookie. Where's that? Sorry about the scrolling, too much scrolling. Yeah, here. So the server confirmed that my credentials, I'm logged in successfully. So the server created a session for me. So it's here. So now the server sent we could see the network part first, because I want to show you the response headers. See, so once the server created a session on the server, it now sends the set cookie there. So there's two cookies sent. One is the actual cookie, and then one is the signature. We're gonna figure that out later. And once the browser receives that, the browser saves that here, application cookies. And this is per domain. So let's say if you're visiting a lot of websites, you're gonna have one for Facebook, one for Google, one for this, one for that. But this is our domain, localhost 4000. And since this is a very simple implementation of cookies, we could actually decode this. You could just go to is it base64 encode? Yeah, I think it's base64. You could actually decode that here. No, sorry, decode. We want to decode here. So decode. Wait, that's not base64. Sorry about that. Okay. Oh, that's the signature. Sorry. The signature we can't really decode, but the session. Okay, so that's a signature, and this is the cookie. Sorry about that. So here we can see that when we decode this actual string, the cookie, that's the thing that we set from the back end. You could add more stuff here, and that's what websites do, is that they send you cookies, and then your browser stores them. And I think that's what I wanted to show here. So now that you're logged in, the server also kind of did a courtesy here that, okay, I'm sending you the cookie, but I'm also redirecting you to the resource you want. So the user doesn't have to go there manually. So the user directed us to resource. That's good. And right now, I know that the user's logged in, but if I delete these cookies, right, and I refresh, I go to research, it's still available. So that doesn't make sense. This request to the server /research didn't include the cookie because we deleted it, and the server still served resource because the reason is in our resource we're not restricting it yet. So that's what we're doing here in the next section, is that, okay, it's a pretty simple check. If the session exists, or in other words, if the cookie submitted by the client in the client's request includes the session, we redirect. Sorry, if it doesn't include the cookie, or if the session's not defined, we direct them to log in. That means they have to log back in if the cookies are not here. Else the cookies here, it's verified by the library. Don't worry about it. We get the resource, and then we finally render the resource, and it's 6.4, right? So we check that out here. Cool. So did you see that? I'll try that again. Okay, we log in successfully. It's good. So whenever we request resource, it's good because we have the cookie. But the moment we delete the cookies there, we re-request resource, it's not good anymore. And I just want to show that these things should work like I said, per browser windows, if I open an incognito window here, I shouldn't have access to the resource, which is what happened. It redirected me to log in because I don't have the cookies there. You could do all sorts of experimentation here. What if I copy the cookie here? I think it's gonna work because right now it's a very simple implementation of cookie, this library that we're using. If you want to be more advanced, use the cookies. I know that it's somewhere. I think it's Express Session. That's more secure. Like I said, I just want to show you that the cookies have a meaning, and you could decode them. But most of the time, they're gonna be encrypted like crazy, or like encoded in a way that you can't even really know what's in there. And that's it for the web server authentication. For the token-based authentication, I might go through this one a bit quicker because we're running out of time, and I wanted to give you time to do the survey. But I think I'll just try to finish this chapter, and you know what? I'll let you do the survey later, because we actually have some important stuff here. So while session-based authentication is the kind of the standard for web pages, like here we have web pages, what do we use for REST API? So for REST API, we use something called tokens. So the concept of tokens, it's this self-contained stateless piece of data. What you notice about cookies is that cookies are stateful. This cookie says something about the user, and so now the clients and the server kind of had a stateful communication. The nice thing with tokens, and it's really useful for REST APIs, because you might have like so many scripts connecting to your server for REST API. It's better to have stateless, so you're not saving all of those sessions, because if you're saving like sessions for at 3,000 users or something for REST API, that's not really scalable. So that the thing with cookies is once a user registered and they authenticated successfully, the server gives them a cookie. So it goes like this: server logs in, sends credential, but it's a different endpoint now. It's an API token endpoint, for example, and then the server creates a token on it from its side and sends the token. So the client kind of just, okay, I'm gonna save this token, and then it's actually the client code that has to save this token. It's not saved by the browser automatically. So for each request, the client code has to manually attach this in a header. Usually it's an authorization header, and then the server checks if this token is valid, is it expired, is it from this server. Same thing as before. A very common standard for tokens is JWT, like this. So the tokens are in a format that's kind of standard, so you could even use a debugger here to decode it, like here. So we're gonna try that out after. A little analogy in the token, think about it as like all-day pass to an amusement park or public transportation like La Ronde or STM. You had that token, you can have access to all the rides. It's a day pass, right? So unlimited access for a day. It expires at some point, and someone has to scan it just to make sure it's valid. You didn't just created your own ticket. Someone has to scan it. Oh, that it's actually from that entity, or in that case from our server. And then sometimes it could be limited. It could be scoped. Your token might only work for specific rides and for a specific amount of time. So all of those restrictions, that's up to the server. But the token is kind of that. It's like a stateless token, basically. If someone steals your token, they could still go in, technically. That's a security thing, but I would skip that for this workshop because we don't have a lot of time. So what we do for JWT is, let me just check file. So we had the JSON Web Token thing. Install that. So in our post API token, this is the route that receives the credentials from the user, and if the user is good, if it's a known user, the server sends a token here. So creates the payload for a token, sets the expiry, and uses JWT sign for to create the token using the payload and a secret key, that same thing that we used before, and we put the expars in. Let me just sorry, I forgot to close my window. All right, so and then that's it. We send the token along with an authentication successful message. So let's try that out here. Actually, if that thing works. If that works, that means this request should technically give me a token back. All right, it gave me a token because I registered already as in the server before, so the server already knows about Eleni with this password. So it gave me the token, and like mentioned before, this is JWT. You could decode this here, so you could go JWT.io. So there you go, Lenny tree, and then other stuff. The nice thing with tokens too is you could insert authorization information. Authorization means like what does the user have access and stuff like that. Authentication is making sure that the user that you are who you are as a user. Authorization is what do you have access to, what are you allowed to do, where can you go in this server. So there's that distinction. So you could also attach stuff there. You know, you could imagine you could attach like a lot of things there, and authorization scopes are a common thing to put there. And on our check, when we check it back from our API, from our resource, what we do is auth index resource. Yeah. So what we do on our check for a gated resource is that we just check if the token is given, and usually a token is given in a authorization or x-axis token header, and if the token is not supplied, we error out. And then this whole thing is the JWT is the library. It does all the verifying along with the secret like before. The library takes care of most of those cryptography things because it's really complicated math stuff behind the scenes. You don't want to just roll out your own. If there's an error, that means unauthorized user. If it's successful, we just give back the requested resource. So we're actually gonna try it here now that we have a token. So yeah, this is the last thing I'm gonna try, and then after that I think we could close off. And then so now that I get the token, so I got the token there, copy paste that. Let me just put that somewhere here so I don't lose it. So now we could try to access the resource. Let's try this. Here we're not passing a token, so no token specified, it's an error. And let's try this. It's obviously a bad token because it just says blah there. That's not a good token. Let's say actually putting a token here. So I'm just gonna do some copy pasting here because it's a really big. Usually these tokens are really long, so you don't want to like mess it up. All right, so that's it. We attached it there. Invalid signature. Oh, wait. Did I? Okay, did I copy that correctly? Authorization from server. Okay. Weird. Valid signature. Okay. Let me try that again. What we did before. Huh. Weird. Okay. Let's try a new token. So I just got a new token, and I put it there. Authorization resource. Okay, cool. Phew, that worked. I don't know, maybe this token expired right away or something, or it was a typo. Anyway, so now we got the resource that we wanted because the server verified that it's good, and you can see the logs there. Or actually, we don't have any logs on that part. So yeah, but that is that part. You could experiment with a config here. You know, you could make it maybe let's say instead of 24 hours, you could make it 15 seconds or something. That's actually part of the challenge. I invite you to try that. And there's this part, it's just kind of a bonus. Yeah, this is just kind of a bonus, right? Now that we have this REST API and token-based authentication, we just want to try it out, because right now we can't. It's nice to try it out on curl, right, in a terminal, but we get to really try it out on an actual front-end code. That would be nice. So I invite you to really take a look at this one, follow the steps here, because we have some little surprises here. I'm gonna spoil it for you, but one problem that we're gonna have here is course, and there's a really long discussion here on course and how we solve that. It's something that you must have faced before when you went to a hackathon. You're trying to use this API. You have your front end, and your front end is trying to connect directly to some server somewhere, and you get a course error like this. And that's actually a security feature. So that's a browser's way of making sure you don't get attacked with CSRF. That's cross-site request forgery. So all the details are here. Basically, the solution for that is we just add, from our server side, we just add these headers, just to let the browser know that, hey, I know this server that's requesting this resource. Kind of like a whitelisting kind of thing, but here, because we want to kind of take the easy route, we just put everything as good. So yeah, anyways, try to really go through this last part. I really encourage you to do that. It's really useful for you if you're going to hackathons and you're trying to connect to a server. And lastly, there's a part here where we just organize our front-end code. And this is kind of an extra. It's not even really part of the workshop, but I'm just showing you here how you could use our REST API if you have front-end code. So this is just vanilla JavaScript, but if you're using React or Angular or Vue or something else, you could easily apply those things there. There's a server aspect to it that you have to make sure that you're setting the right headers and stuff like that. But yeah, I think that's pretty much it for this chapter. So try the challenges, and then the last part we didn't get to see it, but this is more on how do you connect to other APIs like Spotify or Giphy, or there's other APIs that we use there. So definitely check this part out. I'm gonna do a poll in the Slack because we're already out of time. I could definitely continue with these parts, and for those who can't continue, feel free to watch the stream. But I'm gonna do a poll right now. If people would want to spend an extra time, or you just really gonna head out. We scheduled it for up to 8:30, so I really understand everyone just gets out. It's really late too. But I plan to stay until 9 p.m. just for any questions or discussions, anything you want to talk about and things like that, and to give you time to do the survey. But I'm gonna do a poll right now, so if try to respond to this, and if you don't respond, it's fine. That means you just really done for the day. I understand. Let me just type this part. Stay for Okay. Okay, so I just sent a poll in Slack. I just want to know how many people can stay and not. But for those who really have to go, uh, it's really, it's just really been oh, let me just put this. Oops. Okay, you know what? Let me use this part. So yeah, so we discussed a lot of things. It's probably overwhelming right now. So if there's a lot of things that you don't understand, it's totally fine. Go through the material. The material would be there for you. And if you have any questions, ask me on Slack. Also, please do the survey. I posted them there, and just keep learning. And if anyone answers yes to the poll, I would keep going for another half an hour, just talking about these last few chapters. But if you have to go, when you have free time, just go through them. Try the challenges. I think it would really help. Not just to learn Node, but also to understand the back end. And if you missed part one, also we have the link somewhere. If that's not given to you, let me know on Slack. I could give you the link for part one. But other than that, thank you so much for coming. It's I really enjoy doing this. And just a little plug again, please do the survey. And I'm also doing mentorships if you're interested in having a mentor, especially in some web stuff. So please message me on Slack. Just send me a direct message. Other than that, I think that's it. So if anyone's staying, I'll be here for another half an hour.